Good afternoon, cohort 12. This is your asynchronous class for 10/5/2020. We're going to go through the rest of the fractions decimal lessons. We will get through metric systems with ratios and probably get into percentages for you. So last we talked about simple mathematics dealing with the factors of 10. We had stopped before we got to changing decimals to fractions. In order to convert decimals to fractions, you have to count the number of decimal places that the decimal has occurred. So in the case of the example here, we have 0.457. That 0.457 has 3 digits, which means it's in the thousandths. So you would write the 457 as the numerator and the 1000 as the denominator, and that would equate out to being 457 1,000ths. Once you've done that, if you have the ability to, you would also reduce it. That one doesn't have the ability to be reduced. And the next one we have there, right? So 2.75. Well, we can reserve the whole number 2 until the end. And then we count the 0.75, which goes out 2 digits, which means that we're in the hundredths place. We write 75 as over 100, which is what we have here. We can reduce that 75 over 100 to 3/4, which means that our total answer then, adding the whole number plus our fraction, would work out to be 2 3/4. It's not as difficult as it seems, as long as you make sure to count your decimal places and then place that over the appropriate regiment of 10 that you would have. So here we have converting 3/4 to a decimal, right? So we have 3 over 4. How would we do that? You would just do a simple thing, add a placeholder to the zeros, place a decimal point. But in reality, what you're just doing is doing long division. You're dividing 4 into 3. 4 into 3 goes 0.75 times. You can also just look at simple digit there and know that 3/4 is 0.75. 0.75 is 3/4. That's common math. Just like 1/3 is 0.333 repeating, right? 2/3 is 0.666 repeating. Some of those fractions are just simple common sense that we exist in the everyday world, right? A quarter is 0.25. And we know that because 25 cents is also a quarter. So what if you can't divide it? Well, then you're going to end up with that remainder, right? In this case here, we have 1 over 3, which comes out to 0.33333 repeating, which is what I said, right? The book says put it as 0.33 and 1/3. By standard math rules, you don't want to do that because you don't combine a decimal and a fraction in the same answer, right? The better answer for that would be 0.33 or 0.3 repeating. Either way you would do it, as long as that, if you look down here, we have that little line over that 3, that little line, or the dot in some cultures also use it that way, means that it is a recurring decimal number. It's a repeating number. So either way you do that doesn't matter, honestly, to me. But the 0.33 and 1/3 would not be the most appropriate math answer. So converting Fahrenheit to Celsius, this is why we've been going through this. We are going to have to do decimal conversions or temperature conversions in PT. So these are your formulas. You can either use the fractional formula or the decimal formula. I tend to think that the decimal formula is a little bit easier to deal with, because I don't have to deal with any fractions. But you can choose whichever one you want. So to convert Celsius to Fahrenheit, right? We're going to take the Celsius degree. So if we had something like 0 degrees Celsius, we would multiply that times either 9/5 or 1.8, which are the same thing. They're the equivalent of each other. And then we're going to add 32, which, because Fahrenheit has that weird 32 adjustment, that's what we're going to take it to. So like 0 degrees Celsius would work out to be 32 degrees Fahrenheit, which we know because 0 degrees Celsius is freezing in Celsius. 32 degrees Fahrenheit is freezing in Fahrenheit for water, right? And then converting Fahrenheit to Celsius, we just do the reverse. So instead of, dividing here or whatever, or instead of first of all, here we go. Get my brain straight here. First thing we're going to do is take out that extra 32. And then we're either going to multiply times the reciprocal, right? Because we had 9/5 up top. We'll multiply times 5/9 at the bottom, or we'll just divide by 1.8. Kelvin is the common temperature we use in physics. So when we talk about sciences, we will talk about that, right? Kelvin, don't let it trick you. It's a pretty easy thing. To convert to Kelvin, you just have to have the Celsius degree and add 273 to it. Now, the book will say it's 273.15. 273 will get you close enough to an answer that you can pick it out of the multiple choice. And the reason why we'd have to deal with Kelvin is because Kelvin directly relates to energy, which we will talk about when we talk about the transfer of heat and energy. So some common equivalencies here, right? Meaning things that we're going to encounter in the real world that are that equate out to each other. We know 12 inches equals 1 foot, unless you're going to Subway, and then their foot longs are 9 inches, right? That's supposed to be a joke. I don't get as many laughs because there's not many of you here right now. If there are a lot of you here, I'm really concerned because it's late at night. 3 feet to equal a yard. 1,760 yards equals 1 mile or 5,280 feet. 100 centimeters equals 1 meter. 1,000 meters equals 1 kilometer. When we get down to measurements of like volume and stuff like that, 3 teaspoons is 1 tablespoon, 8 ounces 1 cup, 2 cups 1 pint, 2 pints 1 quart, 4 quarts 1 gallon, and 16 ounces equals 1 pound. The more important column is the one over to the right, where we have 2.2 pounds equals 1 kilogram. That's important because a lot of times the patient will be able to tell you how much they weigh. They'll say, I weigh 150 pounds. But your EMR, your emergency medical record, or your electronic medical record, will only measure in kilograms. So you have to be able to convert that 150 pounds into kilograms, right? 0.45 kilograms goes about, well, 0.45392 kilograms equals 1 pound, so about 0.5 kilos per pound. 1 foot is about 30 centimeters. 1 yard, just about a meter, right? 0.9 of a meter. 1 mile is about a kilometer and a half, 1.6 kilometers. 1 ounce is about 30 milliliters, and 1 gallon is just about 4 liters, or 3.75 liters, right? And that can really come into play because I jokingly have seen people that have gone to Canada and go to get gas and like, man, gas is so cheap here. What they don't realize is they're measuring it in liters, not in gallons. And then when they get the final bill, it's basically the same prices that we would have here, unless you're in California, and then it's ridiculous expensive there too. Standard rulers, obviously, what we measure here most of the time in the United States is in inches, but we are converting slowly, and because physical therapy is a science, we are mainly moving over to the metric system. But the main thing I want to get off of this slide here is please pay attention to your ruler. Some rulers are divided out into 1/8 of an inch as the top one here, right? And why is that important? Well, because, you know, this first line isn't 1/10 of an inch, it's 1/8 of an inch. So that can really throw your measurements off when we're talking about girth or leg length, and we'll talk about those in therapeutic exercise 1, right? So in this case, there are 8 parts, 1/8, right, that equate out to 1 whole inch. At the bottom here, we have a ruler that's measured out in 1/10 of an inch. That happens. Some of them come in 1/4 inches. You have to just pay attention and know what your measuring tape or what your ruler is measuring in when you are measuring it for patients, right? So for example, right here, I've got a standard good old-fashioned tape measure, right? My tape measure is measured off in 1/10 of an inch. Great. Now, if I pull out a different tape measure, that tape measure may be measured off in 1/8 of an inch. That makes my measurements essentially the same as far as measurement wise, but I have to make sure I document them properly, because this one I would put down, you know, as 1 7/10. The other one's going to be a little bit different because I can't get as close to that 7/10. So when we go into tenths, that makes things just a little bit more accurate for us, right? Okay, so let me change my share here. And we're going to talk about metric, ratios, and proportions, right? So metric, ratios, and proportions. The metric system is a easier system to deal with personally. I dealt with it when I was over in Europe quite a bit. We're going to talk about ratios when we're talking about proportions. Metric is based on decimals in a base 10 system. It's quickly becoming the normative standard for healthcare, as it is in every other country except for here. And why? Because we're America. We can't do what everyone else is doing, right? We still have weights, we have dosages, food intake, height, length, liquid medication, anything like that. It can be measured by the metric system, just like it can be measured by the standard system. So when we're measuring volume, right, which is like liquids, blood, urine, we're going to measure that in liters in the metric system. When we're measuring weight, we measure it in grams or kilograms. If we're talking about people, we typically measure it in kilograms, right? Where those 2.2 pounds equals 1 kilo. And then length, we usually measure it in meters or centimeters, depending upon what we're measuring. If we're measuring the whole height of a person, we might actually measure them in meters. If we're measuring something like the length of a somebody's foot or the length of a toe or length of a wound. We're typically measure that in centimeters. If we have a wound that's up in the meter range, we've got some major problems and probably that patient's not going to make it. I'm just saying. So mnemonic for remembering units. There's a couple of them out there. You have kiss hairy dogs, but drink chocolate milk man. King Henry died basically drinking chocolate milk man. I don't know who came up with these. I just was always taught to remember we have kilo, hecto, deca, then we have our base unit, deci, centi, milli, and we go all the way out to micron. There are some between milli and micron, but mainly the micron is what you want to worry about. We're not ever going to measure anything. And when we get down to those micro, we're going to talk about like microvolts or millivolts. So don't worry too bad about those. Deci and centi, obviously in measurements, we will. And then, kilos, typically we're going to go above the base when we're dealing in the healthcare system. We're not typically going to talk about hectometers or anything like that. So in form metric unit, we put the prefix plus the base element or the root, and that'll equal the metric unit. So milli plus meter, millimeter. Kilo plus meter, kilometer. Centi plus meter, centimeter. Centi plus liter, centiliter, right? So together, the prefix and the root indicate the type of measurement we're looking at, whether we're looking at volume, weight, length, anything to that effect. Every metric prefix may be combined with every root. So kilo can go with grams, kilo can go with meters, right? Kilo can go with liters. All of that can be combined together. To avoid careless errors when we're talking about metric, use a 0 before the decimal point that doesn't include a whole number. So if we have 1.75 micrograms, we can write that as 1.75. If we only have 0.65 micrograms, it's probably better to put 0.65 to avoid making mistakes and somebody thinking you're putting 65 of something. It's a totally different measurement. 65 micrograms is significantly more than 0.65 micrograms, right? But you may drop non-trailing zeros in mathematics, of course. But in science, if we have significant figures, you may have to keep them. So in the case that we have here, 1.5 grams, 1.5, 1.500 grams are the same thing. But in mathematics, we're going to make it simple and just say 1.5 grams. So let's look at the bottom here. Which one of the following is least correct or incorrect, right? So we have 4.80 milligrams, 3.5 grams, 1.09 liters, 0.9 liters, 90.059 grams. Looking at that, we have two that technically would be incorrect when we're writing them out, right? 0.9 liters really should be 0.9 liters to avoid mistakes. And 4.80 milligrams, right? That technically should be 4.8 milligrams as far as math is concerned. So in healthcare, sometimes the doctor's orders comes in micrograms, but your supply in hand comes in milligrams. Well, you're going to have to convert it. You change units within the metric system, just count the spaces from the number you're going, and you either go right or left with the decimal. So looking at this one, 7.37 grams, or 74.37 grams. We're just going to move the decimal point 3 spaces to the right to get to milligrams. So 74.37 grams equals about 74,000 milligrams. 3,000 milligrams equals 3 grams. We're going to move that decimal point to the left for that. Depends on which way we're sliding, whether we're going to the base above, the number above the base or the number below the base. But whatever it is, it's all about the base, no trouble. 3,000 kilometers. Well, it's 3,000 meters. Sounds a lot longer in meters, but they're the same. 120 grams is 120,000 milligrams. 4.25 kilograms is about 4,250 grams. A lot of this is going to come into play when we start talking about calories, right? Because whenever you have some sort of something, whether it's a drink, whether it's food, caffeine, whatever it might be, a lot of times when we see calories, it's listed as, for example, I'm going to take this one, for example. I can't use this for an example. That has no calories. But something like Mountain Dew, right, has, I want to say it's 350 calories per can or something like that. But what we don't realize, and we'll talk about this when we get to physics, is calories, when we talk of them, has a capital C, not a lowercase c. And the reason it has a capital C is because it's actually kilocalories. So a base 1,000 over. So when you have 350 calories, what you really have is 350,000 calories. Why do we convert like that? Well, we convert like that because if we don't, it would really make us feel horrible. Imagine drinking 350,000 calories. It definitely affects your psyche more than that. It also makes it easier if we just do the capital C. So drug label notes that your client's medicine has 250 milligrams in 5 milliliters of syrup. How many milliliters would deliver 125 milligrams of medicine? So you would set this up as 5 milliliters over 250 is equivalent to X milliliters over 125. And then you're just going to solve it out, right? So move the 125 over to the other side, multiply both sides by 125 basically. 5 times 125 divided by 250 is going to tell you it's 2.5 milliliters. That's a lot of work. What I would do in this case is I would look, I'm going, oh, I want to deliver 125 milligrams, which is half of what I have in the total dosage, right? So when I look at this, right, I have 250, I have 125. 125 is half of 250. So if that's half, that's got to be half, which means it's 2.5. In that case, I wouldn't even do the math. I would save myself the time if I had a question like this on my test and just go, oh, well, that's half, so the other has to be half. My answer is 2.5. So in syringes, the measurements don't include the trailing or the leading zero. So in this case here, right, we have 0.1 milliliter, 0.2 milliliter, everything like that. So we have to understand that. Again, not as important for us because we're not going to do as much medicines, but we will deal with it with like I said, dexamethasone and acetic acid. Ratios shows a relationship between two things, objects, items, amounts, stuff like that. It compares items in our daily life. You know, how many hours are you at work versus how many hours are you away from work? How many hours do you spend at school versus how many hours do you spend at home? Lately, that's kind of a moot point. How many hours do you spend in school versus how many hours you spend out of school can be really important, right? How many hours do you spend watching a lecture or spending time in a lecture versus how much time you have to spend outside of class reviewing for that lecture? The number of yogurts eaten versus the number of yogurts in the fridge. For me, that's really simple. They are the same. It is 0 because I don't like yogurt. It helps you compare these. When you talk about proportions, we're comparing two equal ratios in a mathematical equation. So it allows for increases or decreases as part of the ratio and equation, right? So we're looking at proportions. We're going to look at two ratios and compare them. So a ratio shows a relationship or comparison. So here we have like 3 nurses to 4 medical assistants, right? So it could be measured as 3:4. It can be written as 3/4. It can be written as 3:4. It can be written as 3:4. There's a couple different ways we can compare it. It's just comparing two different items. The relationship in a ratio can be simple, right? 1:3, 1 can of orange juice concentrate to 3 cans of water to make Tang, that type of an idea. Relationships are really just fractions that represent a part to a whole relationship, right? 1 slice of pizza versus the whole 8 slices in the pizza. That would be a ratio. So that's kind of what we're looking at. Often we will simplify and use the fraction format to reduce the ratio to the simplest form, right? So for example, I'm going to use a patient that breathes in. We're going to talk about ratio of breathing in versus breathing out when we get to the active cycle of breathing in semester 4 in Dr. Reskin's class. We have to measure how long it takes a patient to breathe in versus breathing out. Most patients should breathe in for the same amount of time they breathe out for, right? So even if I breathe in for 2 seconds, I should breathe out for 2 seconds, right? Even if it's a 2 second to 2 second ratio, we've got to reduce that. That's a 1-to-1 ratio. Sometimes you'll have something like patients that got COPD. That COPD patient often has a higher breathing in ratio to breathing out, which means they're retaining air in their lungs. Eventually that can become a problem. So they may breathe in for 3 seconds, only out for 1 second. That's a 3-to-1 ratio. We have to then increase it. We'll talk about that when we talk about the active cycle of breathing, where with actual patients that have COPD, a lot of times we're going to try when they're actively concentrating on breathing in for half of what they breathe out. So a 1-to-2 ratio. So they breathe in for 1 second, they're going to breathe out for 2 in order to help clear that dead air in their lungs. Again, we're always reduced the ratio to the simplest form. In this case, we have 8 to 24, which means they have a 1-to-3 ratio. Drug labels use this all the time. Milligrams to milliliters of stuff, micrograms to milligrams, milligrams per tablet, milligrams per milliliter, right? They're all in there. So in this case here, we have lorazepam, right? Which is an anxiety medication. In this case, we're looking at, for every 1 milliliter vial, we have 4 milligrams of lorazepam. If we wanted to give the patient just 2 milligrams of lorazepam, right, we're going to have to give them 1/2 of a milliliter. If we wanted to give this patient 8 milligrams of lorazepam, we need 2 vials because each vial only has 4 milligrams, right? So that's kind of the important thing when we're talking about these ratios, understanding that that is literally saying 4 to 1, right? That helps us understand our ratios and proportions. Medical loss ratios used in managed care is to measure the cost of percentage of premium revenues or income, right? Desirable ratio is 17 to 20 or 85% or less. We're looking at how much money the overall company is making, right? They really want to make money. Comparison of 2 items. Here we have a pack of gauze strips cost $4.10, and there are 24 strips in each pack. Well, how much does each gauze strip cost? Well, it's a 17 cent if we divide it out, 17 cents per sheet or strip, right? So 17 to 1 is the ratio, or $4.10 to 24, which are equivalent. Proportions, take 2 or more equivalent ratios or fractions and compare them against each other, right? In terms of the first ratio, the same relationship to the whole box as the second ratio. So in this case, we have 1 box of gloves equals 100 gloves. If we have 4.5 boxes, right? That means how many gloves are we going to have? Well, if we know 1 box is 100, we know that 4 boxes is going to be 400. We have half a box left. That's 50 gloves, right? So that means if we have 4.5 boxes, we have 450 gloves. And if the glove does not fit, we must acquit, right? Or change gloves. The double colon means is or is equivalent to is what we talk about ratios, right? So when we talk about this, we have an equal sign here. We can just as easily put that double colon. That indicates we are doing a proportional measurement. So we're looking at this one down here, right? 3 to 4 is the same as 15 to 20. So here we have a problem with decimal numbers. So we're looking at 0.25 milligrams to 0.8 milliliters is equivalent to 0.125 milligrams to how many milliliters? Okay, well, we've got to figure this out. There are a couple ways we can do this long method out here. But again, if I'm doing this, I'm looking at this a lot more simple than this whole math problem is here. This is the long way to do it. It's great. But if your brain can start thinking on the next level, you can look at this and go, well, I have 0.25 here. I have 0.125 here. That is half of 0.25. If that's half of 0.25, then this X has to be half of this. Oh, look, it is 0.4 milliliters. So if you can start thinking a little bit ahead of yourself, you can save yourself a lot of long work. So here we have carbohydrates to grams, right? For every 4 calories, you use about 1 gram of carbohydrates, right? So if we have 400 calories, we can figure out how many grams of carbohydrates we're eating. Well, that makes sense. If 4 to 1, 400 is going to be 100, right? But this is the math problem to set it out. And that can be important, especially when you're managing your carbohydrates or your protein intake, to know what your calories are going to be like, especially when you look at fats, right? When you look at fats, they have a lot higher calorie count per gram than anything else. And that kind of makes sense. We understand not all fats are bad for you, but high levels of fat may not be the healthiest thing for your body, right? All right, so here we got a Monster Energy drink. Yay, right? So when we're looking at this food label, there's a couple of important things when I look at this label it tells me, because most of us are going to get this Monster Food Energy drink, and we're going to drink the whole can, right? It's 8 ounces. This can here is 12 ounces, right? So it's 4 ounces less than this. But looking at this Monster Energy drink here, the can itself is 16 ounces, right? So it's a little more than my can of soda. But we're going to drink the whole can. We don't realize is that whole can is not 1 serving. Look at it. That whole can is 2 servings. Because I've seen people go, well, I've got this Monster Energy drink here, but I'm only taking in 110 calories. Well, no, not really. You got to look over here at the per can. And now they're starting to require them to put this stuff on there because they used to just be tricky. And this stuff wasn't on here. It would just show the servings per container. It would show that each serving is how much. You'd have to do your own math to figure it out. That's a little bit deceptive in marketing, right? So you got to pay attention when you're doing this. Of 27 grams of sugar in that one serving. But then you look at it, that's 54 grams of sugar per can that you're taking in, right? That's going to give you that nice buzz of sugar. But then the other problem to that is when that goes away, your insulin levels are going to crash and you're going to come crashing down. Right, we've got all our vitamins listed out. Look how healthy this drink is for you. It gives you 200% of riboflavin, niacin, vitamin B6, and vitamin B12. Where if you're healthy and eating some vegetables, you've already got that anyway, so you don't need that supplemented, right? Sodium, that's the big one here. Look at that. So, sodium says that's 370 milligrams of sodium per can. Let's take a look at my Diet Coke and see how bad I am. My Diet Coke or Coke Zero here has. Where's my sodium? 40 milligrams per can. So I'll take that. That's a little bit better than what we got here on this thing. It makes me feel a little bit better about it. As long as I don't drink like 70 cans of Coke Zero in a day, I should be okay. But in this case, I've seen people pound these down, in a 4-hour class, 3 to 4 of these. You drink 4 of those and you're up to 1.2 grams of sodium, not milligrams, grams of sodium in that 4-hour period. That's not healthy for you, right? That can really affect your overall hydration level because you think you're drinking this because you're trying to hydrate, but by drinking that much sodium, now you're dehydrating, and now you have to drink more water, which you get thrown in this vicious cycle. So please pay attention to what your drug labels say or food labels say is on there, right? Every day we convert between systems all the time, right? 1 gallon, 16 cups. We talked about that. 1 gallon is also 4 quarts. We got the pints we can calculate out there. If you're doing something where you're talking about, measuring out for specific drink amounts, right? Or you're mixing up specific amounts of ultrasound gel to medicine, you have to be able to measure these specifically and convert because sometimes it'll be in ounces, sometimes it'll be in milliliters. You've got to be able to think on the fly and convert between them, right? So to measure height, we're going to use feet, inches, meters, centimeters. To measure weight, pounds, ounces, kilograms, grams. And there's that weird one in England too, that's stones. We won't even talk about that one. That's not really that important. To measure liquid volume, we have gallons, quarts, pints, tablespoons, cups, teaspoons, right? Medication doses are usually in tablespoons or teaspoons, right? When you're talking Dimetap for your kid, you usually give them a half teaspoon, which is that little tiny thing, or a little dropper full of it, right? It'll say like give 3 milliliters of Dimetap. And mind you, Dimetap's not so that you can put your kid to sleep on a flight. Not good. Not Benadryl's not either. Don't do that. That's bad. Right. But we all have to. How many of us actually pay attention to our doses? I know plenty of people that are like, they get a headache and they just go in, they grab a handful of Tylenol and pop it. We talked about Tylenol last time, that how Tylenol is pretty hepatotoxic, meaning that it affects your liver pretty bad. You have a certain amount that you're allowed to take before you really get into that toxic level. I actually had a family member that was the way he attempted to commit suicide, was he downed a whole bottle of Tylenol, right? And I don't know how much you know about if somebody does something like that. One of the things they're going to do is they have to get that back out of you so they can pump your stomach, and they can also give you stuff that actually makes you vomit. It's Ipecac. And honestly, that stuff, if you ever encounter it, smells like maple syrup. And I was the one that took him to the hospital. And to this day, because of that smell of that medication when they were giving it to him, I kind of get uneasy just smelling maple syrup because it makes me think about that, right? So, measure your medication, know what you're taking, right? That includes supplements because, I see people taking creatinine. I see people taking stacker pills. I see people taking L-theanine, right? Make sure you know what is healthy for your body. A lot of these supplements aren't regulated by the FDA, so we don't know how much is needed in our body to function. be careful with that. You can really throw yourself into a toxic problem really quick. The new TikTok trend that's going around right now, I don't know if you guys have seen it, I don't know if it's new, but it's newer TikTok trend, right? The Dimetap challenge, or not the, I'm sorry, the Benadryl challenge. They're having people do TikTok videos where they down full bottles of Benadryl, right? Benadryl has a couple really nasty side effects, right? Benadryl is an antihistamine, which calms down our histamine. And I could go into a whole spiel about how Benadryl works on your body, that it can even cause problems with your heart. Will actually speed up the rate of your heart and cause your heart to kind of overload and maybe go into arrest eventually. It affects your brain differently, right? That's why if you take Benadryl, sometimes it makes you kind of loopy. Some people it makes really sleepy. Then there's that 1% of people like me that Benadryl wires out. So I can't even take it. Benadryl is a sleep medication too, right? If you ever go to the store and you're looking at Benadryl for your allergies and you're like, well, I need something to sleep. And you look over and you take something like, not NyQuil is not what I'm, well, NyQuil has it in too. But something Pure Z or something to that effect to help you sleep. If you look at it, you flip it over and you read it, the ingredient is nothing more than Benadryl, right? So be aware of what you're taking, but think about this though. They're challenging kids to drink full bottles of Benadryl that literally can kill you. I have a great video on that if you're ever interested. One of the guys I know did a video about it and how it literally sent a girl to the hospital because she drank 2 full bottles of Benadryl. It sent her body, you know, she had depressants going on, and because her depressant was going on, her autonomic nervous system went into overdrive. So she was getting both ends of the spectrum, almost died from drinking those 2 bottles of Benadryl. And when you've taken them, you're not lucid anymore, so you can't tell people what you took. So you better hope somebody finds them, right? So just pay attention to medication dosages. And it also goes for you parents out there. If you have medications in the house, please make sure the medications are where children can't reach them and they're locked away. The last thing you want to have is your kid get into your medication cabinet, right? Here we have some time conversions, right? 1 minute equals 60 seconds. 1 day equals 24 hours. We kind of know those. We talked about the weight conversion. 1 kilogram is 2.2 pounds. 1 pound is about 16 inches or 16 ounces. I was looking ahead. 1 foot is 12 inches. 1 yard is 3 feet. 1 meter is about 39 inches, right? We've talked all the way through these before. Liquid measurements are over there for you. Mr. McKeever, what do I have to know here? Well, the good news is when you get out in the field, you may have to know some of these conversions. But if I give you a question on your quiz about this, I will say 1 kilogram equals 2.2 pounds. Your patient weighs 50 kilograms. How many pounds does the patient weigh? That'll help you get through that problem. In the real world, you have to know that conversion. Again, positive note, if you're in the real world, Google will convert this. You literally could type into Google, how many kilograms is 220 pounds? And it'll pop up and say, hello, 220 pounds is 100 kilograms. Google has really made our life both easier, but it's also kind of dumbed us down quite a bit because we don't have to know these off the top of our head. So let's look at 45 kilograms. We're going to convert this to pounds. So we've got something that weighs 45 kilos. We want to convert it to pounds. Well, we know that for every 1 kilo, it's 2.2 pounds. So we're going to multiply that 45 times 2.2, right? And we have 99 pounds. If we wanted to check our answer, I don't know why I didn't completely fill this out here. If we wanted to check our answer, we could go back and say, okay, 99 divided by 2.2, and does that give us 45 kilograms? Yes, it does. Our answer is correct. We move on. Always check your answers. All right, well, that was quicker than I expected for the decimals lecture. Now I want to talk about percents, which is the big portion of this lecture because it's the large percentage of this lecture. I'm so funny, right? Why are percents important? Well, percents come into all of our life, right? Right now, percentages are going to talk about your grades, your grade point average, and all that fun stuff. It's a weighting of grades. It'll come due with your student loans and student loans in general. Your percentages are kind of important for that, right? So they're another part of the whole relationship, much like decimals and fractions, usually related to a whole item or 100% of something, right? So if I am giving you my all, I am giving 100% of myself. Is it possible to give 125% of yourself? I know people said, I'm giving you 125%, coach. No, you can't do that. You can never give more than you have. right? That's not possible, right? It's not like somebody, you give somebody $100 and you're like, that's all I have. And they're like, well, can't you give me 120? Well, no, I just gave you $100 and told you that was all I have. So that literally is 100% of what I had in my wallet. I can't, moths don't have anything else in there, right? It's represented by that percentage sign. Don't forget the percentage sign when you've got questions. If something's asking you what percentage is this, you need that symbol. So in the case of like 35%, it can be converted either fraction format or decimal format. 35% is like saying 35 over 100 or 0.35. 135% is 1 in 35 100ths or 1.35. 3% is 3 over 100 or 0.03. When you are dealing with percentages, I'm going to say very rarely are you going to be looking at the decimal or the fraction format. So it's great to know, and it's easier to help you calculate the decimal because I can go, okay, it's 35 over 100, divide 35 by 100, I get 0.35, right? Or the other thing you can know is, in order to convert a number to a fraction, right, I can just, or convert this to a decimal, I just have to move my decimal point 2 spots to the left, and I get 0.35. So let's say I have 746% increase in therapy production for the day. If I wanted to convert that to a decimal, I'm going to take my little happy decimal point here. I'm going to jump it 2 spots to my left, and that is the equivalent of saying 7.46. Okay, so it's 746%, 7.46. Let's say I have something that is, let's say 64%. To convert that to decimal, I just move that decimal point 2 points to the left, and 64% is 0.64. If I want to go the other way, and I already have a decimal, say I have 7.17, and I want to convert that to a percentage, I just move that decimal point 2 points to the right, and it has 17%. Let's clear these real quick. Let's say I have 1.13465, and I want to convert that to a percentage, right? Again, I'm going to take this decimal point, move it 2 spots over. So I have 113.465%. I talked briefly about this when we were talking about the Ebola, or not the Ebola, the infection rate with COVID, right? So you're just going to move it one way or the other, depending upon if you're going to decimal or going to percentage. Percentages can show up on medication labels, medication containers, strengths of solutions and medications. We're going to talk about that when we get in physics, talk about molarity. On loans, where we're going to encounter loans and taxes, right? Student loans, car loans, home loans, all of that. And then discounts on markups in pharmacies and stores, right? You always love it when you go to the store and something's 50% off, right? But, how many times is it 50% off? And then if you look at it, they've marked it up 195% to start with. So you really aren't saving anything anyway. All right, so to convert a percent to decimal, we talked about shift the points 2 places to the left in order to go the other way, right? So 35% becomes 0.35. To go back to percentage, we just move it back to the right. 0.35 becomes 35%. Here we have 23 2/3, right? We know that 23 2/3 is the same as saying 23.6666666 to infinity, right? We're just going to move that decimal point again, and it becomes 0.236 repeating. 97% is 0.97, 95% is 95. Well, why are these important? Well, it helps us calculate things, right? It's going to calculate percentage to a whole. So here we have kind of the standard formula. It's called the box method. I wrote it out up here, but I think the box drawing down here kind of helps make it a little bit more sense, right? Our certain percentage is going to show us the parts of a whole. So in this case, you get 35 out of 92 questions correct on a test. First of all, you didn't do so great, right? But so you got 35 of 92 questions correct. what percentage did you get? Well, looking at that already, I can already know in my head, if I am doing this problem on a test, I know that my answer is less than 50%, because I know that 46 is half of 92. I didn't even get half of my questions right. So I can go down to my answers and knock off everything that's greater than half. Most of the time, that's going to leave you with one answer. If it doesn't, maybe you've got something that is, 38% and something that's 22%. Well, then you've got to do the math and figure out which it is, right? So this is the way you kind of calculate it out long ways, right? 38.4 cents. Then again, in this case, you better work harder next time. There are easier ways to do that, right? There are much easier ways to do that. If we look at this, 35 out of 92, we can just simply divide 35 by 92 to get our decimal equivalent of fraction or percentage. So 35 divided by 92 is 0.3804. We can then shift that decimal point 2 places to the right, and then we get our percentage. So you got 38.04% correct. Not a very good score. I think you got to work harder next time, like a lot harder. So let's look at this. You need approximately 67% on your NPTE to score and achieve a score of 600, which is the passing score. Now, we're going to talk all about the NPTE, which is your test to become licensed as a physical therapist assistant. Some people will need 67%. Some people might need 72%. Some people might need 50%. It depends upon how hard of questions you get. So that varies, but on average, it's about a 67%. You can do 67%. Come on. You've got to get 2/3 of your answers right. You can do this, period. The psychometricians that designed this test, who are just psychologists that specialize in testing in numbers, on average, if they took the test, they can get 45% right, not be in physical therapy, right? You can get 22% more, and you're in a physical therapy program as long as you pay attention through the program, right? So when you get your test and you sit down to take your test, it's 4 hours long. Oh my God, what the heck? 4 hours, Mr. McKeever, that sucks. Well, in reality, it's how much time they give you. Your test is 200 total questions, 100 questions, right? So 200 total. Oh, where's my little marker? Let's change color. Let's see. Let's go with dark blue right now. So you have 200 total questions. Well, the funny part is only 150 of those are scored. And then there's 50 unscored that are called preliminary or test questions. Those are questions they're fielding out to see if they're good enough to make test questions. You won't know which is which. They're interspersed in all your 400 or your 200 questions. They don't tell you. It's kind of an unfair game, in my opinion, right? But you have 150 questions that you need to get a certain 67% out of, right? So if we look at this, if we need to get 67% of 150, what we need to first of all do is convert that 67% to a decimal. So I'm going to move that decimal point right here. It is, binger banger. So it's 0.67. I can take 150, multiply it times 0.67, and that will give me the number of correct answers I need. So you need approximately 100 questions right. On the last grouping of tests, which I think was in April, the average was you needed about 95 out of 150. So it was a little bit harder. Sometimes it's a little bit easier and you might need 102 out of 150. But think about this for a second. You need about 100 out of 150 questions. That means you can get 50 wrong. Think about that for a second. You can get 50 wrong and still get licensed. You can do this, right? Don't ever think you can't. As long as you pay attention and you study and you do well, you can get a 67%. You have to get a 77% to get through this program. If you can't get a 77%, you can't even sit for the test. You can get 67%, right? So let's do one more here. Let's say, and again, we'll talk about this arbitrary number of 600, but let's say you want to get an 85% on your MPTE. You want an 85%. It's not about what your passing score is. You know, if you get 85%, you're definitely becoming a PTA, right? So you want to get 85. That's your personal goal. So I want to get 85%. How many questions do I have to get right? Well, first thing I have to do is convert this 85% to a decimal. Binga banga. So I've got to get 0.85. Now I need to multiply that 0.85 times 150, right? I got 0.85 times 150. So then you've just got to do the math on it, right? And you're going to multiply it out. So break out your little calculator, 0.85 times 150. And that comes out to be about 127.5. Well, you can't get 0.5 of a question right. So that means you need to round it up, you get 128, and you'll get above an 85%. When we start prepping for your score builders and test prep, right? The score builders is one of the companies that helps us get ready for the test. When we start doing that, one of the goals will be to get an 85% on one of your score builders tests, because if you can get 85%, you can get 67% and you can pass. I have faith in everyone that gets through this program. As long as you work hard and you work with me and you work with Dr. O'Neill and you work with Dr. Ovresky and you work with Dr. Sokel, you can do it. I know you can. I've seen people do it. So percentage of changes, we can either increase or decrease something, like changes in medicine, changes in weight, 401k, everything like that. Typical formula is the amount of change divided by the original number equals the fraction of change. Just remember, change is to be expected in our life, except from vending machines. They always keep your change, right? But for the rest of life, change happens. That's just the way it is. You are changing your life right now by sitting in my math class. I don't know how, because I don't know if you're learning anything. I hope you are, but you are changing your life right now in math class. So let's look at this. You go to see your doctor and you weigh 150 pounds in my right leg. Just kidding. Your doctor and you discuss your weight and find that your ideal weight should be 120, meaning you need to lose 30 pounds. Upon changing your diet, changing your habits. I don't like to say diet because diet indicates temporary. If you want to stay that 30 pounds down, you've got to change your habits. You got to change the way you eat, right? You got to change yourself. That's why I'm the way I am. It's because I like food. If I want to lose weight, I got to change my habits. Either really up my exercise, which I'm not willing to take myself to the level where I'm going to be spending 4 hours exercising, or I need to change my diet. And that's probably what I probably should do. I'm just going to be honest, although I don't eat that much. Anyway, sidetrack. So you want to lose 30 pounds. You lost those 30 pounds. Good job. Congratulations. You did it. What's your percentage change in your body? Well, in this case, we changed it by 30 pounds. Our original weight was 150. So if we go 30 pounds over 150 is equal to 100 over, or percentage over 100, bing, bang, boom, multiply both sides by 100. We get 30 times 100 over 150. You've changed your body by 20%. Think about that. 20% of your original body weight is gone, right? Alternatively, you could just say 30 divided by 150, get the decimal and move it to one place, right? Because 30 divided by 150 is going to give you a decimal point of 0.20. Move that 2 spots. Now you got 20%. Makes it a little easier. There are always easy shortcuts. You just have to make sure if you do your shortcut, you check your answers. Always check your answers. And don't forget the percentage point, percentage sign. Don't let Mr. McKeever cheat you out of an easy question. All right, so we got a patient's doctor here says they are morbidly obese and they've got to lose 30% of their current weight before they will do a total knee replacement with that patient. Well, doc, I understand, right? I am 457 pounds. I really got to lose weight because at 457 pounds, there's a real good chance that patient's not coming out of surgery because we put them under on anesthesia, all that weight on the heart, that can be a problem, right? So doc says, I will do your total knee replacement for you. I know you need it, but you've got to do something for me. You've got to lose 30% of your weight. Patient's like, oh boy, right? But even think about this for a second, 30% of their weight. Let's even think 10%. 10% of this person's weight is 45 pounds. That's almost half some of you. I've seen you guys. Some of you are, just under the 100-pound weight. Right? It's half of you. This patient's got to lose 30%. So they've got to lose 45 pounds times 3. So we'll look at it. How we do it? Well, the original weight times the percentage of change will equal the total weight to lose. Here we have 457 pounds, right? And we need to lose 30% of it. So we're going to convert that to a decimal to 0.3. Patient needs to lose 137.1 pounds. Good golly, Miss Molly, right? So the goal weight for that patient is going to be about 319 pounds. Think about that something though. 137 pounds. I'd be willing to bet if we look at your class, because I've seen you guys as pictures, that's a good probably quarter at least of our class, if not more, body weight meaning. So that person's got to lose at least one of you. Think about that for a second, right? I've seen patients that are 800 pounds and they lose 50% of their body weight. They lose 400 pounds, right? And here I am struggling to lose 5, right? But it's different. When the bigger you are, the easier it is to lose large numbers and large quantities of weight, because a lot of that weight's going to be water weight and a lot of it's going to be adipose, right? So it's easy to kind of shave off that weight and shave down that adipose. But then when you get down to that final little bit, that's where it gets hard. And I know a lot of you know that, right? Like, I want to get down to 125 pounds. I was 160. I get down to 130, and then it's like 129, 131, 128, 133, right? And it just kind of, the last bit is the hardest thing to lose. And it can get really frustrating. That's where a lot of people lose hope. This patient could get down to like 325 pounds, and they just can't get that last 6 pounds. And it gets so frustrating. And that's where we've got to be cheerleaders, come in and go, come on, Bubba, you can do this. Look how much you've already lost. You can, 6 more pounds is nothing, right? 6 more pounds is nothing. 6 more pounds is your pinky. You can do this, right? Just like I say when you guys are passing your boards, you guys can do this. Don't give up. Let's talk about grades, everything that no one likes to talk about, right? So grades are typically eventually converted to percentages and then given a letter association with them. And then also GPA, or grade point average, right? Or grade point association. So at PIMA here, we have a couple different grades. We have our percentage grades, we have our letter grades, and then we have our GPA. So 93 to 100%, well, that's an A here. Technically 92.5, because we do round up, would get you an A. Now 92.49, not an A. Not an A. You can't do, no, it's got to be 92.5. You got to get that up, right? So work a little bit. You can do it. That A is equal to a 4.0 GPA. We don't break it down to A minus, A plus, all that. An A is 4. So then we have 85 to 92% is a B. That's a 3.0. 77 to 84% is a C. That's a 2.0. 76.5 is as low as you can get. Do not go that low. If you go, that's flirting with disaster down at that point. And that means you're going to be having a meeting with Mr. McKeever or Dr. O'Neill or whatever, whoever your instructor content is. Well, definitely Dr. O'Neill. If you're down in that C category at around grade signing period, which is midpoint in the class, we need to have a talk, because we need to figure out what's working and what's not working, because we got to get you doing more of what works and less of what doesn't work. Now, here's a note. Under 77%, so specifically 76.4 and under, is an F. It's a 0.0. There is no D in PIMA. So you remember how some other schools like UNLV has D, gets a degree. There is no D. You can't get a 1.0 here. It's 2.0 or better, nothing else, right? It's often looked at in order to transfer into other schools and possibly move on to like grad schools and stuff like that. Understand, most grad schools that are competitive will not even look on you if your grade's lower than a 3.33. So if your overall school time is less than a 3.33, a lot of grad schools won't look at you. Right? We even looked at some of your GPAs for somebody that had degrees before to help figure out what type of student you might translate into, right? I've talked about before how I've lost stupid points because of one thing or another. It's just dumb. I don't dwell on those at all. It's not that I can remember those vividly in my head. Ideally, if you want to move on to PT school, I would say you want to have a 3.5 or better. I'm just telling you. I'm not talking about transferring credits because I have no idea what transfers and what doesn't, right? But if you want to move on, really 3.5 or better is what you want to shoot for. 4.0 is ideal. That moves you to the top of the pot, means you're the cream of the crop. But I'm going to tell you, and this is something that I had to have an instructor teach me really quick because I'm a perfectionist. You know, so for my for a lot of my degrees, like my IT degrees and that, 4.0, cakewalk, no problem. PT is a little different. Probably aren't going to end up with a 4.0, grade point average back. I almost said KD because I was thinking of Call of Duty, which is hilarious. 4.0 KD is really good in Call of Duty. Actually, all those would be good KDs in Call of Duty, right? Except for the 0.0. That's pretty much where I am constantly. But I went to PTA school, and I wasn't doing as well. I was hovering and Penn State had the 3.33, 3.66, 4.0, so they measured it out. I was in the like 3.33, 3.66 quite a bit, and that was frustrating me. And one of my instructors came to me and said, hey, look, this is a different world for you. Sometimes you just have to accept that you're not going to be the best in the class. It's the best advice anyone ever gave me, because I stopped stressing about being perfect and started stressing about understanding the concept. You don't have to be perfect. You don't have to have a 4.0. If you want to go on, it's a good idea. But in reality, what you want to focus on is, I mean, I don't say you want to get a 2.0, shoot for 2.0. But you want to make sure you're above that 2.0, you're as high as you can get, and that you're retaining the information. Just studying for a test is not going to help you if you didn't learn the material. Your anatomy lessons that you're learning this semester are going to come back to haunt you for the remaining 4 semesters. So don't cheat yourself out of just by rote memorization that you can throw it away. You need to remember everything that you learn. So grade weighting. This is where we get into some problems, and people don't understand this because people come from schools where they maybe don't use grade weighting. So most schools use a weight-based system instead of a flat grading system. I'm going to show you the difference, right? Flat grading system, there's no weighting. Everything's worth the same. You have a test that's worth 100 points. It all adds up at the end, and you get a flat percentage, right? It puts more emphasis on specific things like testing or lab skills. So let's look at a class together here, right? PMI has a couple of main grading categories. There's PPS, which is your professionalism standard points. I have to go over that with you because I don't know if anyone else has really gone over that with you. So somebody remind me on Wednesday, which is our next class together. I'll bring up the PPS point and talk about it briefly, just so you fully understand it. I know Dr. O'Neill brought it up briefly, but I want to make sure y'all get it. Outside assignments, otherwise known as homework, or just work to do outside of class. It's not all homework. Some of it's like reading and some of it's doing quizzes and stuff like that, right? LS or lab skills, right? It's not in every class. Like math has no lab skills. Physics has no lab skills. So don't freak out and ask me, where's all my lab? This class doesn't have lab, so we don't have to have lab. It's not like anatomy. Anatomy has lab, right? But most of the PTA label courses do have a lab associated with them. Tests and quizzes, T/Q for me, right? Those are anything up to your final. That includes your midterm, test 1, test 2, test 3, whatever you have. Like anatomy is going to have 50 gazillion tests. And then you'll have one final, which is cumulative. All your classes should have a cumulative final because you want to build upon your knowledge. And a lot of my classes, when you start out for the semester, are going to have a cumulative from the previous semester to kind of get you back into gear. I'm building those tests in so that you help keep moving forward and keep not losing that data, right? And then you have your final exam, obviously, which is the thing that everyone dreads. All of these categories should have to give you a total grade, which is a number out of 100%, right? So let's look here. We're going to create a class that we're going to call PTA 013, which is the unlucky physical therapy class. I don't know, maybe people say it's lucky. I'm just going to say the unlucky physical therapy class. Class is a full complement of categories, and the instructor has weighted the class as such. 10% for your PPS. Outside assignments are worth 20%. Lab skills are worth 40%. Tests and quizzes and your final exam are both equally worth 15%. If you add all those percentages up, that will equal 100%. Meaning you've got a full complement of your grade here. But if you're having a class like this, it's important to look at and go, oh, lab skills worth 40%. I better not screw that up. Because you could do fantastic on the tests and quizzes. You could do fantastic on the final, maybe do mediocre on the outside assignments, which is homework. Most people do mediocre because they just don't want to do it, right? But then you bomb your lab skills and you can fail that class really quick, right? So it's really important to kind of look at each section as its own little mini class, because each section is going to be a percentage for you. So we're going to look at this. So we got this class here. So 10%, 20%, 40, 15, 15. So let's say this is a class, how the class breaks down. PPS, almost every class, you're going to have 100 total points. That's based on the PPS PEMA form, right? Outside assignments, you had 10 homework assignments worth 10 points each. That's 100 points for that section. Lab skills, you had 8 labs for 50 points each. Tests and quizzes, you had 2 tests in addition to your final, which were 100 points each for a total of 200 points. Your final was 100 points. Looking at the above, you can see that PPS, outside assignments, and finals all have the same number of points, but because of the weighting, they're going to be weighed differently, right? Even though the final exam, your outside assignments and your PPS all have the same number of points. PPS is only worth 10%. Outside assignments is worth more. It's worth 20%. Finals worth 15%. So they're all varied there. That outside assignments would have the greatest impact on your grade, right? This is how you become a smart student, because you need to know where you're at the end of the semester so you know which ones you have to study the hardest for. Because something like my class. You may be doing okay in it and not need to study as hard for the final because you know you're doing good going into the final. And some other classes, maybe not so much. So here we go. So here's your grades. PPS, you showed up to class. You were always dressed for class. You came in on time, everything like that. So you got all 100 points. Didn't miss a beat there. Fantastic. Good job. Outside assignments, you lost about 20 points doing your outside assignments. You only get 80 out of 150. Lab skills, you get about 350 out of 400. Tests and quizzes, 175 out of 200. And you nailed your final. And you ended up getting a 95 out of 100. So 95% on that final. Good job, you. That's fantastic. But your lab skills are a little slack in there. And that can affect you. If you're doing a flat grading scale, you would add up all your points that you earned and put them over the total of all the points that were possible. So in this case, you earned 800 points. You had 900 possible. You got an 88%. You got a B 3.0. If we went flat scale, but we're not going flat scale. This instructor, we're going to call him Jason, right? Because it's Halloween almost. This instructor has a weighted scale, so that's not the right percentage. This is what most of you are going to come up to me. If this was my class, you come up to me and go, Mr. McKeever, though, I got 800 out of 900 points. That's an 88%. And how did I get X, Y, or Z? Because sometimes that flat percentage will be higher. Sometimes that flat percentage will be lower. And we're going to see what happens with this one. So now we move on. Let's calculate it based on that flat percentage, right? It's not the way it's going to be for the weighted class. Let's look at the next slide here. So we have 100 out of 100 points. That means we got 100% of all of our points there. We multiply that times 0.1, which is 10% of our PPS. That means in that mini class of PPS, we got 10 out of our 10 possible points. Outside assignments, we got 80 over 100, which is an 80%, but it's worth 20%. So times 0.2. That means out of the 20 points we could have gotten, we got 16 of them. Get down here to lab skills. We got 350 out of 400. That's an 87.5. 40% is what it's worth, 0.40. That means we have 40 total possible points there in that class when we figure it out here. You got 35 out of those 40 points. Tests and quizzes, 175 over 200, 87.5%. But this one's only worth 15%. So let's look at this. Big difference between 15 and 40%, right? You got 35 up here. You're only going to get about 13.1 points for tests and quizzes. Ooh, okay. Well, you thought tests and quizzes were worth most. No, that lab skills was worth more. And then we got our final. You rock starred that final, didn't you? You got 95 out of 100. You got 95%. It's worth 15 points. So you totally got about 14.25. Well, now that we've all figured that out, all we have to do is add all those points we calculated over here together, boop, add them all together, and you'll get your grade. So based on this weighting, you got a 92.75, which here's our percentage, that's over 5, so we're going to round up. So you got 93%. Otherwise, you got an A because we weighted those grades. In this case, the weighting worked out in your favor. Think about it. You could have just gotten an 88%, got a B. So I don't want to hear you come and crying. I mean, no, just kidding. It's not, all of you will. If you need help calculating your grades, I'll do one for you. I will help you with the second one if you ever are trying to figure it out and help you figure out what you need to get. Because what helps is, let's say you know everything up to your final. You know all what you're going to earn on all these points. So let's say you get to there. So we know that that final's worth 15 points out of 100, right? Because 15%. And let's say going in, you have a 72. You have 72 out of the rest of the points. So 72 out of 85 points. Because this is 15 more, right? And you're like, Mr. McKeever, I'm failing right now. What do I have to get on my final to pass? Well, you need 5 points total out of this 15, right? So you need 1/3. You can get a 33% on your final and still pass the class. Oh, well, I can do that. Right, exactly. So I'll help you if you're ever in this point where you need to figure out, because this is an important thing. You get to that final at the end of the semester, you need to be looking at all your grades and going, okay, so I need a 95 in anatomy. in order to pass the class, but I don't need a 30% Mr. McKeever's class. Study a little bit for Mr. McKeever's class, study a lot for that anatomy. That's a smart student. That's how you keep yourself from getting burnt out, right? Or maybe, you know, physics comes easy for you and you're like, I don't need this. Great. Don't let yourself slip because you can get caught slipping pretty quick, right? So in this case, like I said, in this case, this one case, the percentage is worked out in your favor. A lot of times it doesn't though. A lot of times students will screw something up where, you know, their lab skills, they slacked, you know, and so then in their lab skills, instead of having 350, they have 150 out of 400, right? Oh boy, right? So 150 out of 400, they've got 37 points or 37%, right? So, and then times 0.4. So they've only got 15 out of their 40 total points for that section. That hurts, right? That, we even say maybe megahertz, right? So don't slack. If you need help figuring out what you need to get for classes, come see me. But I'm only going to do it once for you. After that, you can come and I'll help you. But you need to become a smart student, right? All because you paid attention in this class, you got a 4.0. Congratulations. So what else can we use percentages for? We can use percentages to calculate price increases or decreases. Let's say you're buying a stethoscope from a high-end company that sells stethoscopes like Littman. And they're having a 40% off sale. Woohoo! The original price is $440, which is an actual price for some stethoscopes. I think mine was $380. How much off is the stethoscope and what's your final price? Well, we know we got a total of $440. That's what the original price was. We're paying 40%, we're getting 40% off. So we're actually paying 60% of it, right? We'll talk about that in a second. So we're going to convert that 40% to a decimal, 0.4, multiply it times our number. We're going to get $176 in savings. So we can take 440 minus that 176. We're only going to pay $264. Woohoo! We saved a lot of money, right? 264 bucks. That's a much better than 440. I'll take it, right? We could have also done a little simpler and just said, hey, look, I know that if I'm getting 40% off, right, it means I'm only paying 60% of what retail price was. So I can just say 440 times 60.6, and I'm paying 264. Either of those works, right? Just pay attention to what I'm asking you for. Because if I'm asking you how much you're saving, you're going to have to calculate this. If I'm asking how much you're paying, you either have to do this long way of doing it and come down here, or just do this way down here, which is a little simpler, right? But let's look at one here real quick. Let's say you're going, you find a t-shirt. And last week, the t-shirt was $20. This week, you go back, and the t-shirt is now $40. But they're giving you a 45% off discount. Because they're like, well, you know, we're going to try to save you some money. This is real common for companies to do. Right? You'll go in 1 week and it's 20 bucks. The next week you go in and it's 40 bucks, but they're getting you a 45% discount. This happens on times of the month where, what do you call it, gets cut? Welfare checks get cut. A lot of times if you go into grocery stores at that point when they get cut, especially the first of the month, the prices are higher because they know that more people are coming in to buy. So they'll raise the prices slightly, better to shop towards the middle of the month. Just some little thought or food for thought there, right? So if my original price was 20 bucks, but I'm looking now, I have 40 bucks. How much is 45% of 40? So I can do it a couple different ways. I can say, well, 45% of 40, or I know that I'm going to pay 55% because 100% minus 45 means I'm going to pay 55% of it, right? So 40% times 0.55, right? So that's when you get out your little handy dandy calculator. And what you're going to pay, 22 bucks. So you're like, oh, wow, I get 45% off and I'm paying $2 more than I could have paid last week. They got you. Right? So maybe say, well, I don't need the t-shirt this week. I'll wait till next week when it goes back down to 20 bucks. Unless, of course, you need that Grateful Dead t-shirt. Well, I don't know if anyone wears Grateful Dead t-shirts anymore. I'm showing my age. So interest percentage. Interest percentage on loans, home loans, car loans, personal loans, student loans can cause havoc in your life. All these loan percentages are going to be based upon based arbitrarily on your credit rating, which is arbitrary. And there are many things that can both positively and negatively affect your credit rating. Something as simple as applying for a credit card can knock your credit rating all to heck and back. I put this great link here to Last Week Tonight on credit reports. There is some adult language in it, but I think it would be really beneficial for you guys to watch it. There's also one on student loans that I'll have to find, but I found this one really quick. I'm not endorsing Last Week Tonight, I'm not doing it, but they did a really good write-up on credit reports and how that affects. If you guys don't understand credit reports, this will help you understand it a lot better, right? Lenders take advantage of people who do not understand how your credit report works and how loan percentages work. They really do. I used to work at a car dealership. I worked for Nissan. I used to see the way that our finance manager took advantage of people. They will try to rake you over the coals and get as much money as they can because they will get benefits. They'll get bonuses from the bank if they get you to pay more than you're really thinking you're paying. It's a scummy business. It really is. I'm sorry to say. It's a legit business for most people. Man, some of the ways you can earn money is just by cheating people. It really is. Right? But lenders in the bank also know the same thing, right? Getting a personal loan, getting a home loan, same idea. I just bought a house and man, if I didn't know how interest rates work and know what the closing costs and everything else were working on that house, this guy that I was going through to finish it, the guy that was doing all my final paperwork, man, was taking me to the cleaners over it. If I didn't know what I was doing, I'd have ended up on the hook for $25,000 more than I actually paid because he was trying to rip me off for 25 grand and take a 25K. I don't know if I think I went to the bank, so he'd have probably gotten 10% of it, which means he got a $2,500 bonus check. He didn't get that check from me because I looked at my paperwork and refused to sign until we adjusted my paperwork appropriately, right? And they will take you to the cleaners like that. Typically, the longer you take the loan out, the higher percentage interest may be, right? So a lot of people, when I grew up, car loans were 48 months. So 4 years. Took a car loan out for about 4 years. And then I got to about, when I was 18, then I got up to about 5 years, so 60 months. Now I'm seeing people could take car loans out for 96 months, 84 months, 72 months. Are you kidding me? The average consumer trades in their car in 18 months, the average. Now, not everybody. Me, I drive my cars till I don't need them anymore or they don't work anymore, right? But the average consumer changes cars every 18 months. They know this. You're going to be upside down when you trade that car in, and then you're going to pay more interest. The longer you take the loan out, they're going to give you higher interest, right? The worse your credit report, the higher your percentage is going to be because you're considered high risk for default or non-payment. This is why it's important to understand interest percentages and also knowing your credit score and stuff like that. So let's look at this. Is it better to take a loan out for 6 years for 3% or 3 years for 9%? Well, it can depend upon a couple of things, right? How much is your loan? How much can you afford to pay each month? How much extra do you intend to pay on your principal? Any extra you can pay on your principal in the long term pays down how much you're owning. So let's look at an example here. So you take in $45,000 for that sweet brand new car or truck that you want to buy, and you intend on only paying the amount your bank charged you each month. So if we look at a 6-year loan with nothing down, nothing like that, at 3%, your monthly payment is going to be $685 for 6 years, 72 months. Good Lord. At the end of the loan, you will have paid $50,000. Total interest, about $4,300, right? 3% or 3 years at 9%. Your monthly payment's going to be up $1,400. So it's about a little over double, right? Total amount paid over the loan, $51,500. Now look at that. You're paying triple the interest rate, but in reality, you're not going to end up with that much more owed on it, right? Total interest about $6,500 because of the way things amortize out. So don't freak out totally on that. But even though that interest is tripled, the shorter time frame allows interest to not build up as bad, right? If we had a 9% loan for 6 years, oh boy, you are talking some serious interest at the end of those 6 years because they know you're not going to be on time with that. So there's going to be a clause in there that says, well, if you miss 2 payments, now your interest is 12%. It's on credit cards a lot of times, right? You get this beautiful, sweet little credit card, right? I don't have my wallet back here. I think it's out in the counter. You get that sweet credit card and it's like 3% interest rate. You're like, yes. And you read down, it's like, if you miss 2 payments, your interest rate goes to 26.4%, right? I love my American Express cards. My American Express cards have a ridiculous interest rate. That's why I pay them off every month, right? But I like my American Express cards because of the perks I get for them. I have one of those pretty platinum cards. So why is this important? Student loans. Typically have a couple, I put 2 here, but technically there's 3, right? Yeah. And when I say there's two of it, because there's usually subsidized and unsubsidized, and plus comes as an unsubsidized loan, right? And I rated these based upon the interest rates going up. Subsidized student loans are guaranteed by the government. The interest is subsidized or covered by the federal government while you're in school. So if you take out $25,000 in student loans while you're in school, if they are subsidized student loans, you don't accrue interest. You don't start accruing interest until 6 months after you graduate. There's a 6-month grace period once you graduate, we'll talk about, right? Unsubsidized student loans. Well, now it's not subsidized. It's still guaranteed by the federal government, but your interest is going to accrue the whole time you're in school. These typically have a higher interest rate, right? And, you know, at the end, when you come due, you've now got a great, if you took 25,000 out and you had it for 3 years, right? By the time you're ready to graduate and start paying back, you may be up to $30,000 on that loan because of your interest accrual, right? So you have to pay attention, be smart about your student loans. There's also this 1.5% origination fee I was looking. I didn't realize that actually existed on student loans, which means they are charging you for the luxury of getting a loan from them. Basically, it's a processing fee. You could think of it as almost a loan tax. So if you take 25,000 out, there's a 1.5% origination fee, or, you know, was that 25,000 times 0.015? So they're talking about $375 origination fee. That doesn't seem like a lot, but now you start adding interest to that, that can add up, right? And then you have your plus student loans, which are not necessarily guaranteed by the federal government. There are certain entities of the federal government that cover those, usually covered by other financial institutions. A lot of times they're called parent plus loans for those that are younger that need their parents to help co-sign for them. And then you have consolidation loans. These are often offered after you graduate and allow you to consolidate all your loans into one payment. Because if you have all these, you have subsidized, unsubsidized, and plus, you have 3 different payments you have to manage. That can get hectic. If you're really good at managing money, that's fine. If you're not so good at that, you may want to look at a consolidation loan, but just make sure that you pay attention, because often for that higher interest rate or penalty rates. So a lot of times they may offer you, say, well, I know you've got 2.75%, but you got 2.75, you got 3.0, and you got 3.1. I'll give you a 3.2% interest rate on all your loans in one bundle if you come with us. And so people say, that's great. And then you look at the fine print. If you miss one payment or you're late by 1 day, that 3% goes to 6%. If you miss another payment, it goes to 9%. And this is how people end up stuck in the student loan debt forever, right? And then you've got predatory lenders. Be careful, because anytime you're looking at making any setting loan changes, predatory lenders exist. You're also going to find that your student loans are going to be sold. 1 month you might owe Sally Mac, the next month you own Thea. It just changes. They transfer money over constantly between debt. If you're a good payer, most times you're not going to see that, because that person, that company that owns you, wants you because you're paying on time. But if you're somebody that kind of skips around your payments, your loan's going to be changed hands like 5 or 6 times. And that can get really hard to understand who you're paying to. Now, they're required to tell you 30 days in advance, I think is what it is, if I remember correctly, but don't quote me on that, right? That's why we have this fantastic financial aid department. I cannot say enough about our PEMA financial aid department. They are really, really sharp cookies. So please, before you make some type of a decision on some sort of weird outside loan, talk to your financial aid officer. Don't get caught in a predatory loan that it may kill you in the end, right? Key thing to learn about your loans is definitely not take any more out than you need, right? Oftentimes I hear people that take student loans out to buy a new car, to go on vacation, right? Don't do this. You're gonna have to pay it back in the end. I know it looks like a free loan for right now. It's not. Nothing, no money is free. There is no such thing as a free lunch. You're gonna pay for it eventually. Don't do this, right? If you come upon a bag of Taco Bell that's been sitting out in the sun for 2 days, that's great, it's a free lunch, but man, you're gonna pay for it in the end, literally, right? So remember, there's a good chance that at least one or more of your clinical rotations you're going on may be long distance, which means you will incur more expenses. Some people may only get 1, maybe 2 long distance clinicals. We can't guarantee that we can get everything in the city. Dr. Ovreskin really tries hard. And I think last time we had for our students, we actually had everyone but 2 people that wanted to go out of state or in the city. Fantastic. Doesn't happen all the time. Depends on if UNLV has students out, Carrington has students out, if CSN has students out, Toro, right? So we'll try to keep you in town. But if you do have to go out of town, you're going to incur some expenses, like maybe living expenses, hotel expenses, food, gas, right? Maybe you're gonna I don't know, work in Prim, and you're gonna decide to drive to Prim instead of staying down there. Well, then you're going to incur a lot of gas expenses, right? You may be able to help offset these with expenses with student loan amounts. So make sure that before you go on your clinical rotations, if you know you're going to need some money, get in early to your financial aid representative and talk about it with them, right? Last thing about student loans, and then I'll call it here. So I'm going to stop sharing. There we go. Great. With student loans, when you graduate, you have 6 months of a grace period before you have to pay on your student loans. Now, if you have an unsubsidized loan, that loan will still accrue interest for those 6 months. If you have all subsidized loans, that's basically a 6-month grace period. So even if you want to pay on those, you're much better in the long run if you put that money and you pay it into a bank account and accrue interest on it for those first 6 months, right? But also then think about if you have a lender coming to you and saying, hey, you just graduated, consolidate loans with me. We'll give you 7 months free, no payments. But they're not going to give you maybe that interest-free period of those subsidized loans. So please pay attention to that. Be a smart consumer. Don't let yourself get cheated by loans, right? A lot of people end up in this problem. They end up paying student loans until they're dead, right? And that's the big joke nowadays, right? I look at, I'm not gonna say when I went to school, but when I look at when my parents went to school, or when Bernie Sanders went to school, right? You could go to school for $4,000 and get a degree from University of Penn, or you can get a degree from UNR. Can't do that anymore, right? Things are expensive now. If you look at the way things have gone up in price, the only two things that haven't stayed consistent with income is student loans and car loans, right? Housing prices too, but we'll not talk about it. We're not even going there. So please pay attention to that. Don't let yourself lose money on something simple as that, right? Don't take loans out if you can't afford them, right? I know everyone wants to get that brand new car, right? I'd love right now to have a Skyline GTR. That is my ultimate, if I could have one, I'd have an R34, which is an older one, but I'll take an R35, one of the new Skylines. $82,000 car to $100,000 car, please. Can't afford it, mind you, but I would love to have one. But I just know that's not in my cards. I'm happy with my truck. And I have a little 4-cylinder that I use for commuting around and doing home health. I was smart. Both my vehicles are paid off, right? But then I'm paid off, but I'm paying into a loan almost like I have a car payment, so that when it comes due and I need to get another car, I've already got a nice amount down. Be smart about it. Put money aside, right? They used to say that you should have 3 months worth of salary put aside in your bank account in case you lose your job. I think now you need 6 to 8 months, 6 to 9 months maybe. Some people are saying a year's worth of salary in your savings account because things are so uncertain nowadays. The job market will bounce back. We'll get back there. Once we take care of COVID and everything like that, things will bounce back. They have to. If they don't bounce back, we're in bigger problems than we could ever be anyway. So that stuff will bounce back. It's all about how you can be smart with your money nowadays, right? Some of you guys aren't working. Budget yourself. Don't take out more than you have to, right? This is not the time to go on vacation and extravagant vacations, even though they're dirt cheap, right? Where cruises right now are dirt cheap, but they're giant COVID spreaders. I just saw, today I was watching the Talladega race, and there were thousands of fans in attendance with no masks on. Right? It's not the time to do this type of stuff. Save, put money away. If you have kids, start putting money away now for their college. If you're working a job, start putting away now for retirement. Even if it's not your job that you want to work forever, if you're going to go into PTA and you know this is not your job forever, start putting away for retirement now. 401ks are some of the best ways you can save money. I can do a whole spiel on that eventually too. I hope you enjoyed this lecture. I really like talking that type of stuff. That helps me get out of my normal math type stuff. But if you have any questions, please feel free to email me. This is the end of this lecture, so I will post it within a few minutes once it gets encoded. I hope you guys have a great day, and I'll see you guys in Anatomy Lab. Thanks a lot.